Hello, I'm Dr. Sam Markolf, and I'm an assistant research professor in the Department of Civil, Environmental, and Sustainable Engineering at Arizona State University. And my research broadly focuses on urban infrastructure resilience to extreme events like flood and heat. Welcome to our final conversation in our series of discussions related to biomimicry, resilience, and infrastructure. Today, I'm joined by Dr. Samantha Hayes and Alicia Helmrich. Welcome, Sam and Alicia. Sam, would you like to give a brief introduction of yourself?
Sure. Hi, I'm Samantha Hayes. I'm a researcher looking at biomimicry and engineering, and also a consultant focused on infrastructure sustainability. So after about a decade working on built environment sustainability in industry, I started to get really intrigued by this idea of biomimicry and how we might be able to learn from some of nature's approaches to resilience and regenerative design.
Hi everyone, my name is Alicia Helmrich, and my research is centered around designing more resilient infrastructure. In particular, I am exploring how physical and institutional components of infrastructure can increase adaptive capacity by examining frameworks from other disciplines like biomimicry, but also deep uncertainty, complexity, and leadership.
So Alicia, through this project, you've been leading an exploration of how biomimicry can support resilient infrastructure design. I was curious what a major takeaway of the work has been for you.
I believe one of the biggest takeaways for me has been the emphasis on a transdisciplinary approach and how it can provide guidance for infrastructure managers to design more resilient infrastructure. We don't need to reinvent the wheel per se. What was particularly enlightening is that resilient infrastructure design theory really closely aligns with life's principles, and this shows us that we're heading in the correct direction. We just need to work on transitioning theory to practice.
Yeah, and I think related to that, this project has really underscored the importance of effective science communication. Without that, it is extremely difficult to develop the transdisciplinary collaborations that are needed for the complex challenges of the 21st century. And additionally, effective science communication is often a crucial bridge between theory and practice. So Sam, how about you? Any major takeaways on your end?
Yeah, and building on what Alicia's just said, I think for me it was a really interesting reinforcement of what we already know intuitively, which is that there can be a real gap between advances in theory and the extent to which that makes it to industry and applied practice. And that was really highlighted in the work, as the biomimicry principles aligned really quite well with the theory, but not as closely with what's happening on the ground. And there are so many reasons for that. One is just the passage of time, but it also reinforces, I think, the importance of really proactive collaboration between industry and academia to sort of bring these areas together.
Effective collaboration across academic disciplines and between academia and practitioners, I think, is crucial for the challenges facing our infrastructure and cities in the coming decades, and making sure that the infrastructure is as resilient and sustainable as possible. And I'm encouraged that a concept like biomimicry shows promise for enabling and enhancing such efforts. Alicia, how do you think the knowledge and experience you've gained from this project will change the way you approach infrastructure design in your work and research moving forward?
One thing I want to be is less scared of transformational ideas. Natural systems have tried an uncountable number of designs. However, as an early career engineer, it can be really scary to work outside of the norm. Civil engineers in particular really only get one chance to design infrastructure that will last for decades to generations. But I don't think that means we should limit outlandish ideas and possible designs really during the brainstorming phase.
Yeah, and I found for me, I really appreciated that the work gave us a clear mapping of these biomimicry ideas to those more established concepts and practices. So as Alicia says, we can start to incorporate some of these outlandish ideas in a way that is tied to existing knowledge, that we're grounding these in our existing understanding and research into resilience. We knew that there were connections, but we didn't really know the extent of those connections. So for me, I think in practice, it gives me a really good foundation to have the conversation with design and construction teams on future projects to say, here are a set of biomimetic design principles that can really help us to better align with where the resilience research is heading.
I think it's exciting to realize that there is still so much that can be learned from natural systems and applied to the built environment. And equally exciting to think that we might be on the cusp of some major transformations in the way we think about and design our infrastructure systems. And the fact that infrastructure 30 years from now could look radically different than it does today. And so I think it's safe to say that we've all learned a lot throughout this research. So as we kind of begin to wrap up, Alicia, I was just wondering what you think the major finding is of this work regarding the use of biomimicry for infrastructure design.
We saw in our research a list of core concepts for resilient infrastructure design and a list of life's principles for natural systems resilience. While these lists were itemized, I think the big takeaway is that you cannot achieve resilience with only one of these concepts or one of these life's principles. Instead, you have to have this collaboration of all of them to work together dynamically inside of the system and between systems to truly achieve the resilience that we're looking for.
Great. Well, thank you both for joining us today, Alicia and Sam.